Welcome to part 2 of my series where I'm building a prototype for a garden habitat monitoring system for my seedlings. My goal is to take what I learned from this prototype and create a more robust system to monitor the garden I will be implementing in my backyard. If you missed part 1 of the series, I covered planting my vegetable seedlings in my seed starter set. In this video, I'll show you the sensors and microcontrollers I used for the prototype, in addition to how I programmed the Arduino to accept readings from the sensors. What you see on the screen is a program called Fritzing, which you can use to prototype your projects. Here I'm using it to display the parts to my system and how I connected the sensors to the breadboard and Arduino. The first thing I'll do is look for the Arduino boards I'm going to use. For my first experiment with the sensors, you'll see me use the Arduino Micro. I use this board to help acquaint myself with the sensors. The second board is the Uno Wi-Fi. Unfortunately, it doesn't look like the Fritzing program has the Uno Wi-Fi in their catalog of parts, so I'll just use an Uno for demo purposes. The reason I use the Uno Wi-Fi is because I'll be sending HTTP requests with sensor values from the Arduino to a Java API microservice running in a Docker container. Now what I want to do is get the sensors from the parts list. I had to manually add the moisture sensor to Fritzing. That's why you see this under the category labeled Mine. I'll just go and add this to the board. This sensor works by measuring the resistance of the electric current between the two probes. When there's more water or moisture, there will be less resistance and more electricity will be conducted between the two probes. A value between 0 and 1023 will be provided in the reading. The higher the value, the more resistance. In my experiment, when the probes are not submerged in water or soil, I receive readings of 1023. If I dipped the probes into a glass of water, I was getting readings in the 300s. The smaller board, the hygrometer that is included with the sensor probe, contains the potentiometer with a small screw. You can adjust the threshold values that will get read by an onboard comparator. In similar projects, I've seen the threshold of the potentiometer used to signal a water pump to water soil. I won't use this feature in this prototype, but I am planning to automate the watering, and I'll definitely explore this feature down the road. To wire up this sensor, I'll do the following. I'll connect the positive lead from the probe to the hygrometer positive lead. This is the plus sign. I'll then connect the VCC connection from the hygrometer to the breadboard's power rail. I'll use the second rail here as the positive connection for the rail. I'll do the same with the ground connection. I'll connect the probe to the negative lead on the hygrometer. I'll then connect the ground lead to the power rail of the breadboard. The input connection from the sensor to the Arduino is simple. This reading will be done using an analog pin, so we'll simply connect the A0 lead on the hygrometer to the Arduino micro analog A0 pin. The next thing I'll do is search for the temperature and humidity sensor I use. Once I find it, I can add it to the diagram. The way the sensor works is humidity is provided as a float value signifying a percentage. Temperature is also provided as a float value with its measurement in Celsius. The connection is pretty simple. I connect the green output wire from the temperature sensor directly to a digital pin in the Arduino, with power and ground and the red and black wires connected to the power rail of the breadboard. I should probably color code these wires to make the diagram easier to read. I like my input and output wires to be green, my power wires to be red, and ground to be black. The final step is to connect the power supplied from the Arduino Micro to the breadboard by connecting its 5-volt pin to the power rail. I'll also connect ground from the Micro to the power rail to complete the circuit. I'm not going to go through the connections of the sensors with the Uno. They're even more straightforward than the Micro because the pins are easier to read. Here I'm going through the process of connecting the sensors and the Arduino. My setup is a little different from the Fritzing diagram I created, but all the same concepts apply. The code is relatively straightforward. I first had to get the DHT header file to obtain humidity and temperature readings from the sensors. You can use the Arduino IDE to locate this library. I also needed to define macros for the moisture pin A0 and humidity and temperature digital pin 2. I also had to initialize the humidity and temperature sensor. In the setup function, I made sure to initialize the serial port, which is fairly standard code with the Arduino. I then had to tell the humidity and temperature sensors to begin reading. Inside the loop, I start reading moisture readings from the analog pin A0. And I use the functions built into the DHT header file, read humidity and read temperature, to output values from the humidity and temperature sensor. I can then print out the readings for debugging using the serial print line statement. My final statement tells the loop to wait 2,000 milliseconds or 2 seconds before reading the next set of sensor readings. It was finally time to test the moisture sensor with a glass of water. As you'll notice, when I dip the probes into the water, I receive readings in the 300s, as I previously mentioned. When I remove the probes from the water, I see 1023, the maximum resistance reading. Thanks for stopping by. Don't forget to subscribe and check out the next video in this series where I discuss adding the sensors to my Seedlings starter kit and begin writing sensor data to a Java Spring Boot API running in a Docker container, which saves this information in a MySQL database. Take care, everyone.